Welcome to the deep dive. Think about the sheer power involved in launching a rocket. Just incredible forces at play.
Absolutely.
Today, we're going behind the scenes looking at something vital but maybe not always visible. The FAA, the Federal Aviation Administration, make sure everyone on the ground stays safe.
Right, during those commercial space launches and also the reentries.
Exactly. It's this fascinating mix of really strict analysis and smart regulations.
It really is. We're taking a close look at the hazard control strategies. These are, fundamental to commercial spaceflight safety.
So our mission today,
Our goal is to unpack the methods, the analyses these operators have to use to really understand, and then, crucially, reduce potential risks to the public.
and we've got the source material to help us. Two key documents. First, there's Title 14 of the Code of Federal Regulations, specifically Section 450.107. What's the actual rule?
Lacks the core regulation, yeah.
The what? And second, Advisory Circular 450.107-1X. This is more like the guidebook.
Exactly, the how-to. It gives practical advice on meeting the requirements laid out in the regulation.
So we have the rule and the roadmap.
That's a great way to put it. And, it's really important to get that this isn't just box checking.
Right, not just paperwork.
No, it's a very systematic, forward-thinking approach to safety, especially in an industry that's, constantly pushing boundaries.
Okay, so let's dive in. What's the absolute basic requirement here? The foundation of it all.
Well, at its core, any company doing commercial launch or reentry, they must use hazard control strategies. It's non-negotiable.
And these strategies are needed to meet those FAA safety criteria we hear about.
Yeah,
The ones in Section 450.101.
precisely. Those criteria, 450.101A, B, or C, and the strategies themselves, they're listed out in sections 450.108 through 450.111. They have to cover, all phases of
The whole journey. Lift off to touchdown. Essentially.
every phase, yeah. And what's interesting is the flexibility built in.
How so?
Well, an operator can use different strategies in different phases, maybe one for ascent, another for reentry.
Okay.
And they can even layer them, use multiple strategies within the same phase, if needed, for extra safety.
Right, that makes sense. So how do they figure out which strategies to use? It can't just be guesswork.
Oh, definitely not. The main tool for this is something called a functional hazard analysis, the FHA.
FHA.
That's the central piece for determining the right hazard control strategies for each specific flight phase, whether it's launch or reentry.
Functional hazard analysis sounds thorough. What does it actually look at?
It's incredibly methodical. It forces operators to think through pretty much every way something could go wrong that might affect the public.
Every way.
Well, every reasonably foreseeable way. The FHA has to account for all functional failures linked to hazardous events that could potentially harm the public.
And it also looks at the systems themselves.
Yes, it demands a really deep understanding of all the safety-critical systems on the vehicle. Plus, you need a detailed timeline of all the crucial safety events throughout the mission.
You mentioned reasonably foreseeable. That sounds important. It's not just brainstorming disasters.
Exactly. That's a key distinction the advisory circular makes. It's not about, wild speculation or super low probability sci-fi scenarios.
Okay.
It's about a structured, methodical assessment based on the actual hardware, the software, their known failure modes, real engineering data. It keeps the focus on credible risks.
Got it. So the FHA is this super detailed what-if exercise grounded in reality. What are the main aims of doing this whole analysis?
Several key things. First, obviously, identify the hazards systematically.
Right.
Second, it helps validate if the chosen control strategies are actually going to work against those identified hazards.
What's that?
Third, it can justify using historical data, past flight performance, to estimate failure probabilities.
Okay.
Fourth, it provides the basis for building those complex quantitative models like breakup simulations or malfunction trajectory analyses.
The things that predict where debris might go.
Exactly. And finally, it feeds into a broader flight hazard analysis if this initial FHA shows that one is necessary.
So the takeaway here is that before anything launches, there's this incredibly detailed map of potential failures, focusing purely on the potential danger, not just how likely it is.
That's a perfect way to summarize it. It's about understanding the potential immediate consequence first.
Okay, let's dig into the FHA process itself then. The advisory circular sounds like it really breaks it down step by step.
It does very clearly. Section 7.1.3 lays it out. It starts with system decomposition.
Meaning breaking the vehicle down.
Yeah, breaking the whole system, vehicle, ground support, everything relevant into logical levels, down to, say, specific avionics boxes or engine components.
But not too detailed.
Right. You need the level relevant for public safety analysis, avoiding unnecessary complexity with parts that, don't pose a direct risk if they fail.
Find the right balance. Okay, once it's broken down.
Then you describe what each level does, the functions of the systems, subsystems, components, and crucially, how they interact, their interfaces.
And track everything.
Yep, each function gets a unique ID for traceability. Then you specify how it's implemented, hardware, software, firmware, maybe procedural for ground ops.
And then you start looking for trouble. The failure points.
Pretty much. For each function, in each relevant flight phase launch, ascent, coast, reentry, landing, you name it.
And you can combine phases sometimes.
Yes. If the system configuration doesn't really change between them, you can group them for efficiency. But for each function phase combo, you assess failure mechanisms.
Like what?
Things like, does it function when it shouldn't? Does it fail to function? Does it happen too early, too late, out of sequence? Is it degraded? All the ways it can go wrong.
Okay.
And then the critical part. Assess the end effect of each failure mechanism. What happens immediately to the vehicle? Like loss of control, loss of thrust.
And this is before considering safety systems.
Exactly. Raw consequence first. This defines the potential functional hazard.
So you identify the hazard itself.
Right. And each functional hazard gets a unique ID, or you note no safety impact. Then you assess severity.
Which is usually bad for public safety hazards.
Generally, yes. The AC notes that public hazards are typically assessed as catastrophic. It sets a high bar.
Makes sense. What else goes into the FHA report?
You identify which failure modes need deeper analysis in the flight safety analysis, or FSA, ensuring traceability back. You note the expected system response to the failure.
And connect it back to the public.
Critically, yes. Does this end effect actually pose a public hazard? Debris impact, loss of control over populated areas, toxic release.
Okay.
Only then do you identify the specific hazard control strategy chosen to mitigate that public hazard, again, with traceability.
That sounds like a massive web of interconnected analysis.
It really is. And you also have to identify the verification evidence. How will you prove your strategy works? What data supports it?
Right. Proof is key.
And finally, for computing systems, you identify safety items, their degree of control, and level of criticality. It's very detailed.
It is a template.
Luckily, yes. Appendix A in the advisory circular gives a template structure, which is really helpful.
Hugely helpful, I imagine. Okay, so the FHA is done. Are there, hard rules or constraints on which strategies they can actually choose?
Yes. Section 450.107C lays out two key constraints. First one, if the simpler strategies.
Like containment or wind weighting.
Exactly. Physical containment, wind weighting, or even flight abort. If those alone aren't enough to meet the FAA's risk criteria, those levels in 450.101A, B, or C,
Then what?
then a full flight hazard analysis must be done. It's not optional at that point.
Okay, that's constraint one. What's the second?
The second one is pretty significant. It relates to flight abort. If any reasonably foreseeable failure during any significant part of the flight.
Reasonably foreseeable, like we discussed.
Yes, if such a failure has a consequence greater than 1 times 10 to the minus 3 conditional expected casualties.
That's 1 in 1,000 chance of a casualty if the failure occurs.
Correct. If the potential consequence is that high, then a flight abort capability must be part of the hazard control strategy.
No exceptions.
Well, one exception. Unless the vehicle has demonstrated sufficient reliability, a very high level that the FAA specifically agrees to. But that 1 in 1,000 threshold really shows the focus on preventing high consequence outcomes.
Definitely. Okay, we've mentioned the different strategies a few times. Can we just quickly recap the main types?
Sure. The regulations, sections 450.108 to 111, cover 4 main ones. First, flight abort, often used for expendable vehicles, traditional rockets, intentionally ending the flight safely.
Got it.
Second, flight hazard analysis. This is more flexible, often associated with reusable vehicles. It depends heavily on a really robust system safety program, like the one required by 450.103.
And this is the one that becomes mandatory if others aren't enough.
Exactly. If other methods can't meet the criteria, you default to this deeper analysis.
Okay, 2 more.
Third is physical containment. Think low-energy ground tests or very short flights where you can guarantee any failure debris stays within a controlled area. There's an AC for that too, 450.1111.
Right. And the last one.
Wind weighting. This is specifically for unguided suborbital rockets. Basically using wind forecasts to time the launch so the rocket and any parts land safely downrange.
And the guidance, the AC, gives examples of how these might be combined or chosen.
It does. Section 8 lays out potential determination scenarios, like using flight abort, but needing a highly reliable flight safety system in FSS as defined in 450.145.
Okay.
Or combining flight hazard analysis with flight abort, maybe if the FSS isn't quite highly reliable by the reg's definition, that requires documenting compliance for safety critical systems differently under 450.143.
So different levels of proof needed.
Right. Then there's using flight hazard analysis alone, which is necessary if nothing else works, and that requires identifying mitigations and documenting system compliance very thoroughly.
And the simple cases.
And then the straightforward use of physical containment or wind weighting, provided you meet all the specific requirements for those strategies laid out in their respective sections, 450.11 arrow and 450.111.
So lots of paths, but they all lead to demonstrating safety, which brings us to validation. Just saying you have a strategy isn't enough.
Not even close. The chosen strategy, whatever it is, must be shown to meet those overall safety criteria in 450.11.
And for containment, wind weighting, or flight abort, how do they demonstrate that?
Section 9 of the AC spells it out. They need to show three main things. First, that the likelihood of hazardous conditions causing death or serious injury is extremely remote.
Extremely remote. Okay.
Second, the hazards and the controls need to be characterized accurately enough with enough fidelity to feed into other analyses, like debris modeling, malfunction trajectories, and failure probability calculations.
So the inputs for other safety work are solid.
Exactly. And third, the overall flight safety analysis, which incorporates this chosen strategy, has to meet the FAA's safety criteria.
And if they can't show these things,
then, like we said, they have to fall back to a flight hazard analysis or find some other acceptable means of compliance agreed upon with the FAA.
it all seems very rigorous. And this analysis, the strategy, it has to be submitted to the FAA, right?
Oh, absolutely. Section 450.107, applicants must submit the results of their hazard control determination. That means the whole FHA output functional failures, safety critical systems, the timeline.
And a description of the strategies for each flight phase.
Correct. It's all part of the license application package for the FAA to review and approve.
And it's not just a one-and-done thing, is it? Systems change.
That's a really crucial point. Section 450.211A2 makes it clear. The FHA and the proof that the hazard control strategy is adequate needs to be kept current.
So if they change the design or how they operate it,
They have to update or revalidate the analysis. Safety analysis has to evolve with the system. It's a living process.
So wrapping this up, this deep dive really highlights,
What?
well, just how seriously the FAA treats public safety for commercial spaceflight.
It absolutely does. It's not about luck or just hoping things go well. It's a very structured, analytical, and proactive process.
Starts with that deep understanding of failures, the FHA,
Moves through careful selection and validation of control strategies.
and requires continuous monitoring and updating.
Exactly. The regulations and the guidance, like AC 450.107-1X, they provide this robust framework. It pushes operators to find and fix risks before they can cause harm.
It really makes you think, doesn't it? This incredibly systematic approach to safety in such a complex, high-stakes field. Could other industries learn from this?
That's a fascinating thought. What other activities that seem risky on the surface rely on this kind of detailed, upfront analysis that most of us never even see?
Definitely something to ponder. For anyone listening who wants to go deeper, the actual regulations,
Yeah.
14 CFR Part 450, and that advisory circular, 450.1071X, are out there, publicly available.
They are detailed, yes, but they offer a real window into how safety is managed in this cutting-edge industry.
Well, thanks for joining us on this deep dive.